Once again, a very good evening to all of you and welcome to all for the first section of this FTP. Today, we have the honor of hosting a distinguished expert whose contributions to these fields have been both impactful and inspiring. We are privileged to have with us Professor Dr. Narayan Mahapatra, sir, who is currently serving as the professor and head of the Department of Production Engineering at the National Institute of Technology, Agartala. With an impressive 34 years of experience, Dr. Mahapatra has been at the forefront of research and innovation in industrial engineering, production systems, and advanced manufacturing technologies. His academic journey includes earning a PhD from the National Institute of Technology, Rourkela, after which he dedicated his career to advancing knowledge and monitoring future engineers. Over the years, his research has made significant contributions in various international journals and conference proceedings. His expertise in scheduling, optimization, and robotics application in industrial engineering continues to influence both academia and industry. We are indeed fortunate to have him with us today to share his insights. I am confident that his knowledge and experience will provide us with a deeper understanding of these topics. Without further delay, please join me in welcoming Dr. Narayan Mahapatra. Welcome to the FTP, sir.
Okay, thank you.
Welcome, sir.
So let me share my screen.
Yes, sir.
Is it visible?
Yes, sir, it is visible, sir.
Okay. So let us start. So a very good evening again. So we're starting this supply chain actually. And supply chain is actually a very big area to cover. So out of different modules available in the supply chain, we'll focus on the inventory part. And it's a little bit different from the normal supply chain. We are focusing the target area as the reverse supply chain. As we are talking about this Atal Fdp sustainable manufacturing or the lean manufacturing, initially it was called. So it includes energy, waste reduction, recycling, closed loop manufacturing. So these are thoroughly related to these kind of things. So before starting, let me tell you regarding that, what is a supply chain? You might be having knowledge regarding the supply chain. It's actually, it covers this the outline. See this the complicated nature of the current supply chain. There are different actors playing throughout the supply chain like supplier, manufacturer. I'm talking about the supply chain related to manufacturing. There are two types of organizations available. One we call it as the manufacturing organization and other one we call it as the service organization. So my point of discussion is related to manufacturing organization. I'm not talking about the service organizations. The basic difference is that the output, nature of the output. Here my nature of output, what I am discussing is tangible. That is the physical product. You can touch and feel the output of this organization. So we call it manufacturing. And when it's a kind of service organization we talk about, the nature of output is intangible. You can feel it, but you cannot touch it. Like if you go for a kind of clear demarcation between this manufacturing and service, what I am telling you now, that is the service I am rendering. You can feel the impact what I am telling. You can feel it is good or bad, but you cannot touch it. So that is what the basic difference. So you are also going to cover the different aspects in this Atal Fdp related to service industries also. Some experts are coming as the coordinators are telling, and the HOD was also telling that people are coming from TCS and other IT industries. So they'll put some their views and experiences sharing. Okay. Now, initially, the supply chain, what you are calling, it's just like a chain. Linkage between different departments like this chain, we find there are different links attached in a proper fashion, proper way to get the things to be done. The supply chain is like that. Like in the manufacturing supply chain, we discuss about this supplier, manufacturer, distributor, retailer, and customer. If at any point of time, this linkage between any two factors, any two actors fails, that will lead to complete dead halt of the process. Now, initially, the concept was a bit different. Now, the management is tending towards optimization of supply chain. The initially type of organization, as most of the people we do not know, the initial kind of modus operandi this management was dealing with. Initially, it was a kind of what we call line kind of organization. So only it comes the information from top to bottom, no reverse flow. And what you call it as the throwing the baton across the wall. Like if you go for this supplier, the supplier will supply the kind of things to the manufacturer to be manufactured. His work is over. The manufacturer, he manufactures the thing, send it to the distributor. Manufacturer's work is over. Distributor, he gives the supplies the product to the retailer, his duty is over. So that is what the kind of work or the responsibility each of these supply chain actors were playing, that was limited. So just passing the kind of thing from one point to another. But now things are different. Like if you have, I'll give you one kind of simple example to understand this particular thing. If you have studied or you have seen this 4 into 100 meter relay race. So each of these person, 4 persons are there. Each person covers 100 meter, then passes the baton, that a kind of stick they hold, passes the baton to the other one, and his responsibility is over. Then the second person runs for another 100 meter, passes the baton to the third runs another 100 meter, passes the baton to the fourth. So this is like initially it was passing the baton across the world. But now things are gone, those days are over. Now comes the system is concurrent engineering. Nowadays we are busy with concurrent engineering. We cannot say that our duty is over after passing these things. No. So actually all the people starting from the inception of the raw material to the finished product, even after supplying to the customers also, the responsibility is not over. They keep in touch with the customers also in terms of giving services, taking feedbacks for innovative kind of things, asking for suggestions for improvement. So things continue. So research and development plays the vital role in this kind of supply chain. So this is what the complicated structure of the supply chain nowadays. The most important parameter in this one is the coordination. Coordination, as we know, everybody knows what is coordination. If you go for its literary meaning of coordination, I think all we know what is coordination, how to coordinate with each other, do the work properly. This kind of things we know. We practice this thing also. But in the industry, it becomes much more difficult. So if there is no coordination, might be you are doing your work, but the end result will be zero. Let me give you one simple example. Let me tell you a story. In summer, two persons were working in the field. One person was passing by. He started observing what those people are doing. These two people, out of these two, one is digging a hole, and the person behind him is filling the hole. And they are moving, continuing this kind of work. One is digging the hole, another person is filling the hole. So the person observing this one, he couldn't resist. He asked them, what you are doing? So the two persons simultaneously replied that we are doing our work. Then he asked, what you are doing? One person is digging the hole, another person is filling the hole. So what kind of work is this? The first person said, sir, I have been paid to dig the hole. The second person told that I am paid to fill the hole. So the person asks, what is the utility then? The person answers, these two persons, sir, the middleman is absent. He has to plant a tree. So that is what the coordination is lagging. They are doing their work. Whatever the work assigned to you, you can do it. But check it if it is done in a coordinated way or not. If you do not find it's not done in a coordinated way, net result will be zero. So it will lead to the zero output. Again, if we consider this supply chain, we can take numerous examples. Why the big industries, they fail? Not considering the supply chain, there are things like, if you have heard about this product life cycle. So here also product life cycle plays a vital role in the optimization of the supply chain. Now product life cycle, if you know, then there are 4 identifiable stages in this product life cycle. We can call it introduction, growth, maturity, and decline. So there are 4 stages of supply chain. Product life cycle we are discussing. So product is introduced in the market, growth rate is minimum, then it is accepted by the market, growth rate increases. Then after a certain time you find growth is not that much. So then you know that this maturity has arrived. If you do not take necessary or corrective measures or steps in that particular maturity phase, your product is definitely going to decline. Let me give one example to you in this context. How many of you heard about this Nirma washing powder? Nirma washing powder is a Gujarat-based company, Nirma. The person, the owner of this Nirma, he was serving in the state government of Gujarat as a clerk. Now, because of these financial constraints, he was a kind of, he knows something, BSc chemical, he has studied chemistry. So he experimented and found out a kind of detergent named in Nirma and tried to market it in this in its local areas. Then after getting success locally, he tried to spread it all over the India. Then he started the things, supplying this powder. That powder, Nirma washing powder, the color was yellow. Now what he did, the main thing, now see this supply chain is the supplier, manufacturer, distributor, retailer, customer. Now there is a length of the supply chain comprises of these 5 elements. mostly. At every point of time, when the product is shipping, material is shipping from the supplier to this customer, at every step, some part of the profit is added. Manufacturer wants some profit, sends to distributor, distributor keeps some profit, sends to retailer, retailer keeps some profit, passes to the customer or the consumer. Now what happens? The price of the product, because of this addition of profit at every point of this supply chain, product price becomes a little bit higher. And at that time when Nirma was introduced in the market, the big competitor was Surf. Surf was the main player in the market, detergent market. It happened near about almost 100 years. Surf is ruling the market. But Nirma, as it was available with less price, and people also accepted it. Because in India, there are competitive advantages. There are different competitive advantages like quality, price, this lead time, manufacturing lead time, readily availability. So these are some kind of things we call it as the competitive advantage. And the competitive advantage of Nirma was the low price with comparable quality with Surf. So people started purchasing this Nirma. Now see, here also comes another point, brand name. Surf has a huge brand name. So people were asking Surf in the Nirma in the name of Surf. People are asking, give me yellow Surf. They're actually asking for Nirma, but they are asking in the term of Surf. Surf has such a brand name. So it started, captured the market. Near about now this, if you go for this, that was at the, I am talking about 80s. The financial condition of the people of India at that time in 80s was not that much good. So most of the people were poor. Now these things are changing. People are moving above this kind of poverty line. So at that time, people accepted this Nirma, gained the market, but it failed after a certain period of time. Why it failed? Because it reached suddenly with a very less span of time the maturity level, and it has not changed anything. Now, if you talk about this Surf, initially in our time, but I have heard or I have seen it. It was only Surf with a cardboard package. Then it came Extra Action Surf. Then the name changed to Surf with Wash Booster. Then it came Extra Action Surf. Then it came Surf Blue. Now you are dealing with this Surf Blue kind of thing. I'm not talking about Surf Ultra. There is another category. I'm talking about this plain Surf. Now see, either the Surf is changing the name with a little change in the ingredients, or what you call the Surf is changing the packaging. If you change the packaging, if you change the name, the product behaves as a new product. So when the product life cycle comes to the end of the life cycle, a new product life cycle starts. So Surf is using this kind of thing. So his product is a sustainable product, capturing the market, and still it is running. But as Nirma didn't pay any attention to this one, so it failed. Okay, anyhow. So these are the practical example how Nirma cuts out this supply chain, reduce the profit margin, and give the Surf, that Nirma powder, to the customers with less price, gaining the market. So these are all the case studies. Now, let us move to this supply chain one. for our slides. So this is now, we have shown this complicated structure of the supply chain. Now mark here. This is what the supply chain of a particular detergent kind of farm we see. So these are all related kind of thing. So this figure is being taken from one book, Peter Mendel. So this is a supply chain of the detergent powder. So there are chemicals added to plastic products added, timber company, they are making paper manufacturing, then cardboards. This goes to the Procter and Gamble or other manufacturer of this washing powder, detergent powder. Then it comes to the Walmart, or you can call it as your kind of Reliance Smart, other things. Then comes to the store, then goes to the supplier, sorry, customer. So this is how this supply chain runs in general. Now, if you go for this objective of a supply chain, there are two things we go for. One is the customer value, another one is the supply chain cost. So our intention of the objective, we have to increase this supply chain surplus. Supply chain surplus is kind of thing, we can relate this one to profit. If you go for this customer value, I'm not talking about price. Value is different, price is different. Customer value means the importance of that particular thing. We call it as the value. Might be the price is very high, but you are not valuing it properly, then you are not interested in that one. So that is what the price and the value differs at this point. If you are giving importance, you are feeling it is useful, then you value that product. If you do not find it is useful, then you are not valuing the product properly. Now, here comes one important parameter, pricing. Value is related to pricing also, though these two things are different. Now, pricing means the price tag we find in different products. Generally, when we check it, we check the price of a particular product. We want to buy certain things, so we check the price of that product. Now, by checking the price of the product, psychologically we try to compare it with any product, such kind of product we have procured earlier, or might be it is available, we know it. So we make a kind of comparison, and we find this price is okay. When we think that the price is okay, then we can purchase it. If you do not find this price is okay, that means you are not valuing that particular price, then we are not going to purchase it. So many times it happens, we go to a store, find a product, but we do not value it properly as per the price, so we do not purchase. But if you find this value is okay as the price stated, then we purchase it. That is what we call, when we purchase it, then we call that customer value. So customer valued the product as the price. Then comes the supply chain cost. Supply chain cost is equivalent to the cost of production. That means starting from the inception of the raw material till the finished product. What we do? It incurs some amount of cost. Might be direct cost, might be indirect cost, overheads. So those things are added together. Finally, you get this cost of production. So the customer value, that is the price customer wants to pay, and this total production cost. If you make a difference, we find this as the supply chain surplus, that we call it as the profit. So our intention that we have to increase the supply chain surplus. So there should be optimization kind of thing. So we do that. Now, what are the decision phases in a supply chain? There are three. supply chain strategy or design, supply chain planning, and supply chain operations. If you go for these strategic decisions, always the strategic decisions are long term. The supply chain planning is the intermediate, and the supply chain operations in this day-to-day activities. These are the major decision phases in the supply chain we're interested in. Let us go for this one by one. So this is what the supply chain strategy. So when the strategies are made, this is made for several years. So it decides everything. Where should be the plant should be located? What should be the product? What should be the technology? So these are kind of things we have to discuss. So what do? We want to discuss there also, whether we have to procure the things from outside or produce the things. So a trade-off is made. Like there are many companies, we can call it as the virtual company. They do not make product. They outsource the product, sell it, and still they're existing and getting more profit out of that. So these are the kind of things we go for this strategic decision point. Then we go for this supply chain planning. It is year basis, 1 quarter to a year. That is done. Actually, we make here like a matching between this demand and capacity. Here comes this aggregate planning kind of approach. We do it. And every point of time we want to increase, maximize the supply chain surplus. And if we go for the supply chain operations, it is weekly or daily basis. Day-to-day activities, how to manage, where to get these materials, who will be allocated this particular order, who is going to do this. So these are the day-to-day decisions at the subfloor. So these are the three major decision phases of the supply chain. And if we go for this views of supply chain, there are two views. One is the cycle view, other one is the push-pull view. Now see, these are the cycle view of supply chain, where there are different cycles that has to be done at specific point of time. So first the procurement cycle, then manufacturing cycle, then replenishment cycle, customer order cycle. So at every point of time, one cycle is completed, it reaches to another person or another entity. Not a person, another entity, another system, it enters and the things goes on. So that is called, we call it as the cycle view of supply chain. There is another view, we call it push-pull view. Now push-pull view mainly, it covers make to order, make to stock. Make to order means we try to produce the things as per the customer order. That is make to order. We are making the things as per the customer order. Now what is the advantage of this one? We are not going to store in inventory. We are avoiding it completely. Like your just-in-time Kanban system. So these are included in this make to order. That mainly depends on the customer order cycle. That we call it as the pull process. Push process is different. Push process, make to stock. We do not know what should be the demand, whether it will be consumed or not consumed. But as you are making the things, so get from the things from the historical data, we go for this forecasting, implement it, and go on producing the things. Finally, it is stored as the finished product. Then at any point of time, customer comes and takes out the product. May not be feasible even. Some products might be we get a leftover kind of thing. So this is the basic difference between pull process and push process. Generally, we go for these push processes when the market demand is very high. Then we go for this push. And when the market demand is fluctuating, not that much high, customized products are needed, then we go for this pull process. When the customer places the order, we start producing it. But for this one, your supply chain should be sustainable one. That means everything should be in proper. Then only this pull process works. In the Indian context, very few organizations are implementing this pull process. These people, this JIT system, Kanban, these are the things mainly people in Japan, they are using it. India, we have started it, but not to full scale. Okay. These are macro processes like customer relationship management, internal supply chain management, supply relationship management, all has their periphery or boundaries within which it works. So these are not the point of discussion, we can skip it. Now coming to competitive and supply chain strategies. Competitive strategy, as we know, that is cost, delivery time, variety, quality. So these are all, we call it competitive advantages or strategies. We cannot go for considering all in one. Like suppose you go for this highlighting on cost. When it comes to cost, you want to optimize the thing, we have to minimize the cost. So we want to get the product at minimal cost. But side by side, you also want quality. It's not feasible. When the quality increases, cost also simultaneously proportionality increases. So it is always better to focus or highlight on any particular one. If you go on making this accepting more than one competitive advantage, then you may fail. So remember, cost is one, delivery time one, variety is one, quality is one. So these are the major competitive advantages. Some are given examples, like your this Walmart store, McMaster car. So these are the two things are given. This Walmart, like our this Reliance store equivalent. So we get the product at low prices. And the variety of things you can get it. But what is the kind of competitive advantage here? Low price. You compare this price at any point outside this store, you get the price is a bit little higher. But the another company, if you consider it, this McMaster car, so this is maintenance, repair and operation type of products. It offers more than 5 lakhs products, but through website. Its competitive strategy is the variety and the customer convenience, availability and responsiveness. So these two, there are different strategies. Like he has given another example of Blue Nile and gels. Now here these are diamond stone, gemstone companies they are dealing with. And one is dealing with online, another one has a physical store. So the person who is having this website, he has got a varieties of things you can see it from the website store, but it takes some little bit of time. But you are not allowed to touch it, this jewelries. But in other one, this is a physical store. So you can go touch it and people are explaining the varieties of this kind of things, advantages, disadvantages. So these are the kind of thing we go for this competitive strategy. So always to make the supply chain effective, competitive strategy and supply chain strategy should match with each other. If there's a deviation, then we cannot get much more success in this one. So this is this value chain, we call it relationship between competitive and supply chain strategies. It starts from this product development, marketing, operations, distribution and services. It goes to the customer. It encompasses all finance, accounting, information, human resource, everything. So that is what this, we call it as the supply chain strategy and this competitive strategy. It should be aligned. Okay. Now coming to this strategic fit, we have to go for understanding the customer and the supply chain uncertainty, understanding the supply chain capability, and achieving the strategic fit. Now there are many things, we call it as this cost of the product. So the customer, this a particular segment, you have to go for this market segmentation. If we go for this capturing the entire market, it becomes difficult. So you have to decide who are the customers that should be included in your supply chain. That is the first one you have to see. And what is your capability? How much you are going to supply? Design the supply chain to satisfy their kind of requirement. That has to be properly defined. And then it comes the third one and the final one, achieving strategic fit. So there should be matching between these above two. Okay, you forgot this one. Okay, now mark here. We go for this cost and responsiveness. Responsiveness shows how quickly we can respond to this customer needs. And if you go for this responsiveness to be high, these are the factors under bullet you are finding it. Short lead times to be there, large variety of products should be there, highly innovative products should be there, high service level should be there, and you should be able to handle the supply uncertainty. All these factors directly related to the responsiveness. Now out of these things, you might be knowing this short lead times. Sometimes you do not know. Most of the people might be knowing. I don't know. Lead time is the kind of initiation of a process and completion of a process. That we call lead time. Like if you go for making a lead time of your BTech career, lead time is 4 years. You can say for the time being. Now because of NEP 2020, this is very certainly going to change. We do not know. But for the timing, lead time for your BTech career is 4 years. Might be you can get this lead time sometimes increases because of some reason or other. And when we want to increase your responsiveness, this one we cannot increase or decrease, this BTech lead time. But the lead time, if we go for this making the things available to the customer, customer places an order and is delivered the order. That we call it as the procurement lead time for the customers. So we can sort this lead time gap between placing the order and receiving the order. So the responsiveness will be high. Customer coming to the organization for a particular product. So you should keep a variety of product. Responsiveness becomes high. You have to supply, suppose, some specific innovative product. The customer wants, you are able to supply. Responsiveness becomes high. Meet a high service level. Service level is a kind of thing. This thing we use in probability. Like customer comes to you and you do not have the thing that the customer wants. So customer will be annoyed. So it is a kind of thing may lead to a permanent loss of sale. He may not come to you again. So you have to maintain a stock of these products a little bit higher. Suppose you are getting 90% service level, that means 100 times the customer comes to your organization, 90 times you'll be able to get it. Service levels are generally put very high to satisfy the customers. Responsiveness becomes high. And this supply uncertainty, that also you have to maintain to make the responsiveness high. Now, all these factors directly related to responsiveness, it incurs some cost. So responsiveness becomes more, cost also becomes more. So we cannot say that where responsiveness becomes high, we are satisfying the customers, but the cost also becomes low. No, it cannot be. So if you look at this graph, on the y-axis is the responsiveness axis and this x-axis is the cost axis. You find cost at the left side is high, and what is the responsiveness? It is high. You check the curve. And the cost becomes low, responsiveness also becomes low. So we cannot go for these extreme points, making this high responsiveness for all these parameters, so that the cost will so much high, customers cannot afford. That is one. So we have to go for a strategic fit, where the responsiveness and cost both are taken care and customers are satisfied. So that is zone of strategic fit, we call it. There is the uncertainty of demand, certainty of demand, responsiveness supply chain, and efficient supply chain. These all parameters has to be taken care, and we find a zone of strategic fit. That should be our aim, to find this zone of strategic fit. This is what we are doing. This one is the forward supply chain, we call it. Like, what is forward supply chain? Or the general supply chain we know. That is making the things starting from the raw material to the finished goods. That is the forward supply chain. But our point of discussion will start from this one. Okay, these are the decision-making areas in supply chain. Like that, and also we know this location, production, inventory, transportation, information sharing. These things also we can say it in other terms. Like we can equivalently call it as the drivers of supply chain. So drivers of supply chain are the decision-making areas in the supply chain. All these parameters we give emphasis while making these decisions, and we call these are the drivers, driving forces to increase the supply chain efficiency or effectiveness. Now you can call these facilities, that is the location, inventory, transportation, information, sourcing, and pricing. Facilities means locations. It can be single facility location, multi-facility location. So that has to be checked properly. So there are kind of tools, mathematical tools, established tools available. Sometimes we get it if you are a student from MBA, you know it better. If you are giving emphasis on this industrial engineering or production optimization, then you know how to locate the industry, what are the criteria, and these mathematical models like simple median model is available, your center of gravity model is available, your total or partial covering model is available. So based on that, we can select where to locate. So that is what we call it as the facilities. We can do it. It is already known. Now coming to this second parameter, inventory, that we are interested in. Inventory is practically a stock of anything that has to be kept intentionally. What is the advantage? Advantage is to make it kind of scheduling more effective. So, but when we talk about inventory, it's a part of material management. Materials constitute more than 70% of the cost of the product. Again, we are talking about manufacturing, supply chain. So in manufacturing kind of thing, the material cost around 70% of the total cost. So it is important. But material management has two phases. Items, we call it dependent demand items and independent demand items. Dependent demands, that otherwise called derived demand. Independent demand, that we call it as the direct demand. Now, what is the basic difference between these two? If we go for dependent demand, demand of a particular product, if it depends on the demand of some other item, that we call dependent. But when the demand of a particular product does not depend on any other item's demand, then we call it as the direct demand or independent demand. You can take a very simple example. Suppose you are going to manufacture a car. On what basis you are manufacturing a car, particular model? Based on the market survey or the market demand. So you get the market demand that a particular brand of car of a particular model, we have to produce 10,000 number of units, say, let us. Now we start producing 10,000 number of cars. That the demand of 10,000 number of cars we get directly from this market survey or market research by the method of forecasting. Using some sophisticated tools, we have forecasted it. So that is what we call it as the direct demand. But to make the car available, 10,000 number of cars, how many number of wheels you need? Per car, 5. So you need 50,000 number of wheels. That is for running front 2, rear 2, and another one step. So per car, you need 5 number of wheels. So 50,000 number of wheels are needed to produce 10,000 number of cars. So this number of wheels, 50,000, it is derived from the 10,000 number of cars. So that is called derived demand or dependent demand. Now I think these things are clear. So there are tools and techniques available to deal with dependent demand items and to deal with independent demand items. If you go for dependent demand items, then the tool is the MRP, Material Requirement Planning, MRP 1. There are two MRPs, MRP1 and MRP2. MRP1 is the material requirement planning. MRP2 is the manufacturing resource planning. So here we are talking about MRP1, material requirement planning, that is applicable for the dependent demand items. But for inventories, we deal with mainly the final product, that is the independent demand items. So that is all about the inventory. You should have basic knowledge, being a person from mechanical engineering, production engineering, industrial engineering, from MBA, having some knowledge regarding management or any other field. If you know inventory, then you should know these kind of things. Now again, it is subdivided inventory. If you go for this inventory control, it covers also many things. Like if we go for differentiating different types of inventory, we call it Q system of inventory, P system of inventory. Q stands for quantity, P stands for period. In some inventory models, we find the order quantity is fixed. That is why we call it as the Q system of inventory. And in some part of the inventory, some systems of inventory, after every fixed period, 3 months time, 2 months time, 1 week time, 4 months time, so that period is fixed, we place the order. And the order we are placing is different. So when the orders we are placing is different, but the time of placing the order remains the constant, then the period of placing the order remains constant. We call it as the P system. Some people also differentiate this inventory system into deterministic models, probabilistic models. Deterministic models are easy. Most of the things we assume to be constant, or when things are clearly spelled out without any ambiguity, we call this model as deterministic models. And when there remains some ambiguity in the system, we call it the probabilistic approach models. And mostly these probabilistic models are more practical. Like in deterministic model, we find that demand is constant, but demand is not constant. Okay. In inventory models, there are basically two questions are asked. How much to order? That's the first question. And second important question is when to order. If we are able to get answer to these two questions, whatever be the model of inventory, whether it is Q system, whether it is P system, whether it is deterministic, whether it is probabilistic, if you are able to answer these two questions, how much to order and when to order, then your problem of inventory is solved. So that is what it makes a sense dealing with the inventory. And this transportation, the third important parameters of this drivers of supply chain, that we know transportation models are there. Like you have a kind of store, you have these different service centers. Service centers have certain demand. Your store can supply a limited number of items. So depending upon this one, you are shipping this transporting items from the store to the different service centers. So that you have to manage to minimize the cost of transportation. There are transportation models available. If you have studied it in the operation research, these transportation models are clearly given. So if you are interested to study this transportation model, there are various books available. One very good book is Taha, Operation Research by Taha. And there is another book, very voluminous book by Lieberman. So you can refer those books, better books for better understanding transportation models. So this is in a nutshell. Below we are getting, these are the drivers of the supply chain. and competitive strategy, supply chain strategy, these are aligned with. If there will be deviation, then this total system fails. Then in one side it is efficiency, other side it is responsiveness. Responsiveness, it becomes high, means the cost becomes high. When the cost becomes high, efficiency decreases. So you should be find a kind of previously what the slide we have seen, the strategic fit, so that it takes care of everything, responsiveness and efficiency. So this is all about your direct supply chain or conventional supply chain. Of the supply chain till date we know. But now let us switch over to the reverse supply chain. This reverse supply chain actually is very interesting. So what do we do here? This reverse supply chain came into play because the raw materials we are using to make the product is depleting day by day. Like you want this iron ore or steel industry, bauxite ore for aluminum industry. But how much iron ore is remaining to make the new things? How much bauxite mines are remaining to get the new kind of aluminum product? So these virgin materials, these ores, are depleting day by day. Human population is increasing like anything. So we have to put a restriction or barrier of use of these virgin materials. We have to use it care. So that is the concept of this reverse supply chain. So what do we do? After using the product, we are interested to take back the product. Nowadays, it has been started. And it started in this automobile sectors. You find this Maruti is using this in the form of second sale, true value. Other companies also started using it. You find your this mobile companies, they're also taking back your mobile phones. If you are ordering in this Flipkart, Amazon, they are giving you a value for your old phone you are having. But think of what they are doing with that old phone. That is where the reverse supply chain starts. So they're making a kind of little bit of alternation. There's a product recovery option is there. So once the product returns to the OEM, original equipment manufacturer, they try to set it right so that the product will be useful. So it is basically the product recovery system. We recover the value recovery system. Instead of saying product recovery system, we say the value recovery system. The value of the product depends. What is the value of the product? So it is distributed differently. Sometimes we go for repair, sometimes we go for remanufacturing, sometimes we go for cannibalize, sometimes we go for recycle. So these are different points. Depends on the value of the product, how we want to recover it. Main thing we have to discuss here. First of the things, this reverse supply chain based on the product return. There are varieties of ways the products are returned to the OEM. Why the products are returned? Either they become redundant because of non-functioning properly, or they do not function. functionally they become obsolete. Now here comes the term obsolete. Obsolete is a kind of term when the product value goes on decreasing because of technological advancement. We call that obsolescence. And when the product is not functioning by number of years you have used it, after which the product is not functioning and the product value decreases, we call that process as depreciation. In both of these cases, the product is not functioning. Either it is not functioning properly or it is not functioning because of this technological advancement. Like this, I have purchased one this HP laptop. That is in the year 2005. And I have purchased that one with the price of 56,000 at that time. And it was Windows XP. After that, Windows 7, Windows 8, 10, so many things are changing. Now what happens? I was using XP, then I upgraded it to Windows 7. Then somehow I have made it Windows 8. After that, I couldn't get the update. Now my laptop is working. I am still working on this. But see, I am not able to use higher versions of Windows. Because this laptop will only work up to Windows 8. It is not accepting higher version. So now this becomes obsolete. It is working. No problem in that. So this becomes obsolete. So I have to return it to HP. But I am not returning. I am still using it, interestingly. Okay, anyhow. So there are different ways how the product returns. We call it one manufacturing return. Then second one is the distribution return. So these are the ways, channels through which the product returns to the OEM, original equipment manufacturing. Then the last one is the customer return. So in these cases, your most customer return we are interested in. So customer returns, business to customer commercial returns are there because of this guarantees period, warranty periods are there. Service returns are repairs and other things, product comes back. Sometimes the people call for a particular batch of product, like Samsung in the earlier 6-7 years back, one batch of product is culled from the market. Nano has culled back some products. So time to time it happens. And the most kind of things which we do not return is the end of life return. After the end of life, actually we throw it. And we in India use the product to its last entity. We do not throw it. So now for this, government has made a plan, a lifespan of your vehicles, maximum 15 years, after which you cannot use it. You cannot run it on the road. So you have to use it, that we consider as the end of life. So this is how this reverse supply chain works. Now see, these are the value recovery options available. Depends on the condition of the product. So we have not put here this reuse. Reuse is a kind of thing, is a direct use, as good as new. Only because of some minor imperfections, the thing is not working. So it's not coming under this one. So main product recovery or value recovery options are starting from the repair, refurbish, remanufacture, cannibalize, and recycle. You might have heard this term refurbishing a product, refurbished phones available in your online shopping. You can check it, ask for the refurbished phones, and if the original price of the phone, it happens to be 30,000, 40,000, you get this refurbished phone at a bit lower price. Then we call this remanufacture, cannibalize, recycle. Now, where we have to go for this repair, refurbish, remanufacture, cannibalize, and recycle depends on the condition. Now, see, this table gives you what should be the condition of the product. If we go for this repair, it acts on the product label. And we go for this restoring the product to its working order. Some of the parts, a minor correction is done or replaced without compromising with quality. Refurbishing a particular module fails. So it is all the modules are inspected, and if there are some failing models, they are being repaired or replaced, upgraded to the next level. That is refurbishing. Remanufacturing, it happens to be the part level. Some modules or parts not working are replaced and as good as new. Cannibalization is a bit different. What you do in cannibalization, we check the total product and product is not in working condition. Functionally, that becomes obsolete. So what we do, we take out some selective parts so that those parts can be used in other products. And recycling, it is the material level. We completely destroy the product, and this material, whatever we are getting, that materials we give it to make the new product. So recycling is the worst case of the product where there is no question of the product existing. In all these above, up to cannibalization, up to remanufacturing, actually this product exists. But after this cannibalization where the parts exist, and in recycling, nothing exists, only the material. Like you go for this, some sponge iron industries. There are so many sponge iron industries you find in and around this Rourkela Sundargarh area. So they are dealing with this collected this iron products. So whatever the things made of iron, the customers are throwing it out. People are collecting it, sending it to the sponge iron industry, and they are making the parts iron. So this is the recycling one. Okay. So some literature studies has been done. So what is the conclusion, objective of this literature survey? We have to deal with different models of remanufacturing. Either it is existing or new one. And we have to add the different features to that one. Maximize the profit. Develop deterministic, or probabilistic models. So let us see some models existing of remanufacturing. Now see, in every point of time, we call it closed loop supply chain. When the product is not returning from the customer, is the direct supply chain or straight supply chain. And when the product is returning back, then we call it as a reverse supply chain. Now this production process is there, but there is another process adding to that one, remanufacturing process. The production process gives the product serviceable. The remanufacturing process also gives the serviceable. Now both are combined together here and sold to the market. That is the customer. So many such type of what you call models are available. These are the models, already available models. So you can search for the different journals. You can find these models are available. And there are so many people, they have worked on this. These models are interesting. And I will give you one such model. This model will be a bit difficult. Okay. Let me see to one model. Okay. Okay. So we'll go to this model. Now see this left hand side top. This is what our model shows. So the solid arrow, this is shown. This is the forward channel, forward supply chain, direct supply chain kind of thing. And after the customer, once you find these arrows, dotted arrows, those are the reverse channels through which this after use, the things are coming back, remanufactured, and gives rise to the finished product. So here we have one model, base model we have taken here. Just below that one, left hand side, this model is existing. What the model says, where stockouts are allowed. This T1, T2, this time period when the product level is increasing, then it is decreases, reaches zero level, then the stockouts happens. And stockouts are allowed up to certain period of time, T3, T4, these are the stockout periods. Okay, so we go for a kind of dealing with the back ordering. Then the product process starts again, we are reaching. So at every point of time, we are suffering a little bit of stockouts, and stockouts are intentionally allowed in this model. But when we go for these stockouts, what we find, stockouts, people or the customers or the consumers are not accepting. It may lead to the deprivation of getting the things from the company. So that leads to a permanent loss of sale. So to avoid this stockout condition, in the right hand side, we have made a model. This model we call it as the proposed model. So there are two things. The first one is the combination of direct manufacturing and remanufacturing. And below this one is call it as the remanufacturing only. What happens here? You just look into this one. So the products are collected and remanufactured. The second plant I'm talking about. So the level of this product goes on increasing till we reach a quantity Q dash. Once we reach this quantity Q dash, then in the other one, on the top model, you mark here, this model ends here. The product, this y-axis is the quantity axis, x-axis is the time axis. The quantity becomes zero here. So once the quantity becomes zero, this Q1 number of items what we have remanufactured, that is sent to the top and it is consumed at a rate D. Here P is the production rate, D is the consumption rate. So this small cycle, small triangle that you are finding here, that is replacing actually the stockout condition T3 and T4 in the base model. So whatever the stockout condition here, that is substituted by this remanufacturing. So the big triangle in the above is the large triangle one is the direct manufacturing process, and the smaller triangle we are finding here, it is because of the remanufacturing process. And we are satisfying the customer's demand. So this model, what we do, some parameters we have considered, like this one, demand rate, production rate, holding cost, setup cost for the remanufacturing, setup cost for the raw materials. So number of items manufactured directly, number of items remanufactured. So these are we have quantified with certain numerical values you have given here. Sorry, this symbolize it. Then we start optimizing this process. We have calculated the cost. Based on these models we have cited past. So we have found out this cost. Then to optimize this cost, We have made it partial differentiation method to make it finding out the slope of this one, making it to 0. So D total cost by D quantity and making it to 0, like this one. D total cost by D quantity, putting it equals to 0. So in one case, we find this Q. Q is the quantity for direct manufacturing, and dt by dq dash putting when equals to 0, we find it q dash the value that is for remanufacturing. So now this gives you an idea that how much number of units you have to manufacture and how many number of units you have to remanufacture to satisfy the demand of the customers in the market. So an example is being taken, and this example is dealt with that previous base model which was available, and we find out the total cost in that model, and we find out, considering this direct manufacturing and remanufacturing Q1 Q dash model, and we found there is a difference between this total cost. Now the total cost for this one, once you are getting 49,325.18 per year, and here you are getting 43,000. So the per cycle we are able to save 5,537. So this you can graphically also, other kind of things we can get it. This graph total cost versus fraction return. Now this fraction returns also depends. We cannot get this fraction return equals to 1. Fraction returns equals to 1 means total product going to this direct manufacturing, everything returns, not possible. So it remains within this 0.4 to 0.6. And this profit versus fraction return, profit increases as the fraction return increases. So this is a kind of ideal curve where the fraction returns is 1, but it's generally less than 1. Deal with 0.4 to 0.6. So direct manufacturing quantity, remanufacturing quantity, number of cycles needed. So these are the kind of conclusions you can make it. And also, you can give input to this model. This is a deterministic model we have considered here. You can go for this probabilistic model. So in probabilistic models, what we do? Because of uncertainty in demand, as there is demand fluctuation, we have to keep a kind of service level, or we call it what you call safety stock kind of thing, to meet with the fluctuation of the demand. So that is another part. So I think it's okay for the timing. You can ask, if you are interested to know something, you can ask some questions. Hello.
Hello.
Am I audible?
Hello.
Hello. You can ask
Hello.
some questions if you
Thank you,
want.
sir. Uh, the session was very interesting and informative. Now the session is open for interactions.
Yeah.
Participants can interact.
Okay.
Participants, if you have any questions, you can ask. Sir, there is a query. Can you explain reverse supply chain from Debi Tarun?
Okay. Reverse supply chain is actually see. Let me see. Show you. Okay, you can get any of these reverse supply chain models. Now see, there are things like we move in forward direction, starting from the supply of raw material to the finished product. That is, we call it as the direct supply chain. There is no, I think, kind of things where we getting the return. But when we are focusing on the return, supply chain changes. So that we call it as the reverse supply chain. Like see, so once the product reaches the new items, then it customers then it goes back. Recycle, those are product recovery options we use. But in direct supply chain, we do not have that product recovery options. Product recovery options only comes to play in case of reverse supply chain. So why we call that one as reverse? Because that you see why we call it reverse. You see this one. You see the direct supply chain arrow, this solid arrow, and this dotted arrow. Dotted arrow is backtracking. So that's why it is called reverse supply chain. The model changes. Okay. Anything more you want?
Okay, thank you, sir. There is a query from Chandraprakash Sharma. What are the key challenges in handling e-waste, and how can robotics help mitigate them?
Okay, it's a robotics kind of things. E-waste are different. Sometimes it becomes hazardous in dealing with this e-waste kind of things. There are so many materials to we have to deal with this e-waste. We do not know actually. So mainly robotics is a kind of thing. They are used to work in different hazardous situations. So we can use it like nowadays assembling, disassembling. Both the terms are now becoming important. Assembling the things we know, but now people are emphasizing on disassembly. How quickly it can be disassembled. So when it comes to disassembling the things, retrieval of specific parts, hazardous parts should be thrown away. So there we can use this application of robotics. So that is what we can do, dealing with the e-waste. And there should be sensing devices that can sense properly which parts are to be thrown away, what is the level of kind of this hazardousness. It can be sensed properly. Now the things have become more sophisticated. So we can do it. Use of robotics can be done. Okay.
Okay, thank you, sir. Any queries? Any other participants? Okay, then we'll end the session here.